Hello! The purpose of this video is to help you review equivalent fractions and comparing fractions. So remember, when we compare fractions, we're just looking for which one's greater, less, or if they are the same. But the word equivalent means specifically we're looking for which fractions are equal or the same. Okay, so equivalent fractions are the same. When we compare fractions, we're trying to see which fraction is greater than, less than, or equal to. All right, so let's review. The chart below shows the fraction of an hour that 4 children read their chapter books. Which 2 children read the same amount? So if we're looking for the same amount, we're looking for which 2 are equivalent. So we have a virtual manipulative that we've been using this year, our area models, to help us with equivalency. So if I was going to solve this problem, I would pull out my virtual manipulatives and build each one. So let's build Jamie's amount, 1/3. So 1 is my numerator, 3 is my denominator, and my denominator tells me my total amount of parts. So I know that 1 out of the 3 parts will be shaded in. Okay, and that was Jamie. You might want to add a J for Jamie, okay? That way I can keep track. All right, next I'm going to have Logan. So I'm going to build Logan's amount, and he has 6/8. So 8 is my denominator, 8 total parts, and I'm going to shade 6 out of those 8 in. I can even hit my labels button to check my fractions. Jamie and Logan did not read the same amount. I know that Logan read more than Jamie did because Logan's fractional part is closer to a whole than Jamie's. That's how I know his is more or greater. So I need to keep going. I'm going to go over to Spencer now, okay? Spencer's going to read 2/6 of his book. Well, they're not. They're reading the same book. They're reading for an hour, okay? Sorry about that. So Spencer reads for 2/6 of an hour. So 6 is my denominator, so I'll click on 6, and I'm going to shade in 2 parts because 2 is my numerator. Ooh, if I look carefully at this, I see that 2/6 looks to be equivalent to 1/3. But I can actually move my tool and see, oh yes, they are exactly the same. And I can even lay them on top of each other to see they are the same. Perfect. So I know that 1/3 and 2/6 are equivalent, or Jamie and Spencer. But I could even try the last one, 4/10, just to make sure, because everyone makes mistakes, okay? So if I try out 4/10, I see, oh, that's not the same as any of the others. So it's definitely Spencer and Jamie. Okay? But we always, anytime you find an equivalent fraction, pull out your multiplication chart and check it, okay? Because it's so simple to just check it on a chart. It takes 2 seconds. This is how to check it on a chart, just in case you forgot. So you're going to find the fraction on your multiplication chart. And remember, fractions have a numerator and denominator, so they're going to be on top. Can't go sideways, okay? It has to be on top of each other. So 1/3 we could find here. Yes, there's a digit in the middle. That's okay. We're going to ignore that too. 1/3. So if we look, all the fractions that are in the same row are equivalent to that. So I see right here that 2/6 is equivalent to 1/3. I also can see that 3/9 is equivalent, 4/12, 5/15, and so on. Okay, so that's just a quick way that you can check your work. All right, this model shows 2/8. So I have 2 shaded in, 8 parts total. Which of the following fractions shows an equivalent or the same amount? So I have my fraction model site again. Okay, so I'm going to build 2/8. I like to drag mine out a little bit just to make them bigger. That's what I'm doing with that arrow. So 2/8. And I'll check, yes. So I don't know what's the same. Well, let's look at this first one. This also has a numerator of 2. It's 2, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. This is 2/12. So I'm going to shade in 12 parts. I'm going to put 12 parts and shade 2 in. Those aren't the same. So A is not the best answer. So let's look at B. B has 6 total parts and 2 are shaded in. So 2/6. So I'm going to shade in 2/6, and I see, no, 2/6 is going to be greater than 2/12 and 2/8. So that's not going to be the best answer. Let's look at C, 1/4, because I saw that 1 out of 4 total parts are shaded in. 1/4, ooh, this looks the same as my orange piece, 2/8. Let me drag it up and check. Yes, they are the same or equivalent. I see that 1/4 and 2/8 are the same, okay? But just to check, D has 4 as my numerator, and then 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So I need to plot 4/10. No, that's not the same as any of this. It's definitely 1/4 and 2/8. Okay? But always check it on your chart. 1/4 and 2/8 can be found here side by side on your charts. We know that they are the same. 2/8 is equivalent to 1/4. 1/4 is actually what 2/8 is simplified, because simplifying means to divide the numerator and denominator by the same number. And going backwards on our chart divides those numbers. But I can also tell from this that 3/12 is the same as well. Okay? All right. So sometimes we can have word problems for equivalent fractions, like this one. It says Jennifer has a cake. The cake is split into 10 equal pieces. Jennifer and 5 of her friends ate a slice of cake, so how much cake did they eat? Okay, well, I have a cake that has 10 parts, okay? So I'll make 10 parts. Well, it says they ate. Jennifer and 5 of her friends had a slice of cake. So here's a slice for Jennifer, and then here's a slice for her friends. 1 friend, 2 friends, 3 friends, 4 friends, 5 friends. So altogether, they ate 6/10 because Jennifer and then 5 more friends. But there's a problem. When I look at these answer choices, I don't see 6/10. Okay, it's not there. So since 6/10 isn't there, I need to figure out which of these is equivalent to 6/10. Well, let's do a little bit of reasoning about this, okay? If I'm thinking about tenths, I know that 5/10 is going to be a half, right? Because isn't 5 half a 10? I can kind of use that comparing to half strategy to help me eliminate some of these choices, okay? So 4/8, well, 8, half of 8 is going to be 4, so I know 4/8 is really a half. Well, if my 6/10 is greater than a half, I know that 4/8 is not going to be equivalent to that. So I'm going to move on. All right, 3/5. Well, half of 5 is 2 1/2. 3 is more than that. So I'm going to try out 3/5 because that might be the right answer. So I'll come down here. How many parts? 5. I'm going to shade in 3 of them. 1/5, 2/5, 3/5. Oh, they are the same. 6/10 and 3/5 are the same. And that makes sense because 2/5 would be less than a half, and 3/12 would also be less than a half, since half of 12 is 6. So 3/5 is the best answer, and I can even check that on my multiplication chart. See, 6/10, back it up, that's 3/5. Now this is a little bonus question. It says how much cake is left, okay? Well, if this is how much they ate, how much is left? Well, 4/10 would be left. Or if I wanted to simplify that, that'd be 2/5 is left, okay? All right. So which number line shows a fraction equivalent to 2/8? So we're looking for what's equivalent to 2/8. So I could go back into my fraction model site, build 2/8, build each of these and see which one is the same. Or remember, you can also use your multiplication chart. So let's check it out. 2/8 would be found here, and I see 2/8 is also the same as 1/4, and it's the same as 3/12. So since 1/4 was one of my answer choices, that's why 1/4 is the best answer. Because when we find equivalent fractions, there's more than one way. We have multiplication charts. We can use number lines, okay? We just didn't have a way virtually to stack those number lines, but if you use number lines, you'd stack them on top of each other. But the ways we really covered in class were building those fraction models and looking at that multiplication chart, okay? All right, so as we finish up, I kind of want to go over comparing fractions, but if you know how to do equivalent fractions, comparing fractions is kind of a breeze because you're kind of already doing that when you're trying to see which fractions are the same. So I'm going to compare these two fractions, 5/6 and 7/8. So to compare fractions, just build them. I'm going to build 5/6, okay? And then, well, let me get rid of that so I don't keep getting confused. 7/8. Okay, 8's my denominator, 7's my numerator. Ooh, I see, although they're very close, I see that 7/8 is closer to the whole than 5/6 is. And that makes sense because if this whole is broken into 8 equal parts, those 8 parts are going to be smaller than my 6th pieces would be. Because if this whole is split into 6 equal parts, those parts are going to be greater than 8 because it's not being split into as many pieces. Because think about it. If you're sharing a cake and you're splitting that cake in half or into 2 parts, you get one of those parts. That's a lot of cake, right? But if you're sharing with like 10 people, then you're only going to be getting like 1/10 of the cake. So half of a cake would be much greater than 1/10 because the number of pieces that it's broken into, or the denominator, the smaller that denominator is, the larger those pieces become of the whole. Okay? All right. So remember, just like with whole numbers, the alligator mouth is always going to eat the greater value, and the greater one's the one closer to a whole. Okay? And then this one, 9/10 compared to 3/4. Okay, you can build them both, but I know 9/10 would be greater, okay, because these are both one part away from their whole. And if I'm showing 9/10, okay, look at what I mean about this. If I show 9/10, oops, and remember, if you shade too many, just click it again and it goes away. If I showed 9/10 and then I show 3/4, okay, 3 out of 4 parts, look, they're both one away from their whole, but since tenths are a smaller size piece than fourths when we're comparing to the same whole to begin with, okay, because like, this is what I mean. You can't be comparing these. They're not of the same whole, right? That doesn't matter. But if they're of the same whole, we can compare them and see that these 10th pieces are a lot smaller than these 4th pieces. So 9/10 would be greater than 3/4. Okay? All right. So just remember that comparison, and you are going to see a question like this on your assessment. Which of the following statements is true? Just use your strategies, build each of these, and figure out which one is showing the correct relationship between the fractions. Okay? Remember, we eat the greater one, put the greater than side towards the larger fraction. Okay? All right, you got this.